Hello, and welcome to MarsPod, the podcast about how AI is changing society and the big picture impact it can have on your daily life. Today's episode is brought to you by MarsCrowd, your one-stop data labeling and collection company providing real-life data to boost your machine learning models. I'm your host, Mark Wesley, and today's guest is Sevak Avakians. Sevak is a cognitive physicist whose career has spanned from working at the National Synchrotron Light Source at Brookhaven National Lab under a grant from NASA to working as an electrical engineer in manufacturing within the RF and microwave industries, and as a cybersecurity analyst within the National Incident Response and Intelligence Services team for the Federal Reserve and U.S. Treasury, before shifting his attention back to his childhood passion of artificial intelligence. Sevak, welcome to the podcast.
Thank you, Mark. Thanks for having me on the podcast.
I have to say, I'm really excited to have you. I think that we're going to have a great discussion about artificial general intelligence and a lot of the things that's going on in intelligent artifacts. So if you could just kind of give me a brief introduction of yourself, kind of the timeline of how you became one of the founders of Intelligent Artifacts, like what led up to that?
Sure. So my background is actually in physics. Growing up, I wanted to be a cosmologist and, basically trying to solve all the big problems of the world and of the whole universe. But as I grew up and I realized, I could spend my entire life working on solving a problem that I'll never know if I actually got right or wrong.
Wow.
So I actually came back and decided to work in different industries and worked as an engineer as an electrical engineer for a while and worked as a marketing engineer for other periods. I also worked in cybersecurity for the Federal Reserve and the U.S. Treasury for some time as well. And it was actually there where I was reintroduced to artificial intelligence, something I was actually really passionate about as a kid. As a kid growing up in the 1980s, these AI problems were supposed to be solved within 10 years, right? So, and I remember a friend of mine and I were discussing what we would study for college, and he wanted to study AI, and I tried to talk him out of it. And I said, look, everyone's saying it's going to be solved in 10 years, so one more year of high school and then 4 years of college, and that was about 5 years ago when people were saying all this. So it's going to be solved by the time we graduate. So let's work on something else and find a more interesting problem to solve. And, I've been eating crow since. And I said, I'm going to go into physics, which was my second passion. And luckily, it's actually the skills you learn as a physicist and the methodologies that you develop as a physicist that has helped me build our framework, which is named Gaius. And it was at the Federal Reserve where we had some problems to solve, and I wanted to automate it. And people said, well, you can't really automate that because it requires AI. And I thought, no, this doesn't require AI at all. This is just going to be some clever programming. And I went ahead and I built the system and started using it, and people were kind of like surprised that it was possible to do. And they asked me to take some grad level courses at the local university here downtown in New York City, and for AI courses. And when I sat in those courses and heard that basically no progress had been made since the mid-1980s, I was kind of like obviously very disappointed, and quite frankly a bit pissed off.
Yeah.
Where are our robots, right?
Yeah.
So I started looking at why this failed. What were people doing? Because everything sounded so promising back then. You had these expert systems, which were symbolic systems, that were very successful in solving problems and reasoning and all these other great, interesting things. And you had these neural nets which learn from data, and it seemed like, well, these should be like the holy grail as well. And so somebody's got to finally get a solution that works in a general sense for everything. And it turned out that those promises that were made back then, there was a lot of hype around it. But to be fair, the scientists and engineers at the time, they weren't trying to develop hype. They were trying to develop these things, but they just didn't realize how hard some of these problems were. And it's known that a lot of the hard problems were actually quite easy to solve. And that's like the reasoning aspect of AI. But a lot of the easy problems were actually quite hard to solve. And that's where they hit a roadblock. So I started looking at ways to try to solve that, and taking all the ideas that I had as a kid of what it should look like at the end of the day, and putting it together with my skills as an adult, I was actually able to solve some of those really hard problems and create a framework for AGI.
That's pretty amazing. I want to ask you, did your friend that you convinced not to go into artificial intelligence ever make his way back to artificial intelligence?
So I actually tried to find him because he moved to South America to go to college there, and we stayed out of touch, unfortunately. But I tried to find him, and I couldn't find him for many years. But hopefully, one day he'll reach out.
I see. Maybe he's listening to this podcast one day and is like, "Man,
I told you."
I told you. It's still a big problem. Yeah.
Yeah, you're right.
I think that you're going to be the perfect person to ask this next question to, which is, we ask everybody that's on the podcast this question, which is, what is your AI doomsday scenario? Do you think robots are taking over the world anytime soon?
Yeah, so it's funny. I actually do get that question frequently, and obviously everyone thinks first about Skynet and all this stuff. But the reality is that these AIs won't develop in the way that's portrayed in movies, right? So it's not like you flip a switch, the machine turns on, and suddenly, after a few moments, it's sentient and realizes, oh, well, we should destroy all of humanity so that we have all the resources, or whatever reason it is for that plot. The reality is going to be much more like, to give this analog, how we have evolved with dogs, or how dogs actually have evolved with us. So, early man actually had these dog-like animals around them, wolves and stuff, that would come and scavenge for the food that was left behind by humans. And eventually, those relationships became a little bit stronger, and humans could start trusting those wolves, and the wolves could start trusting the humans, became part of that pack because they're both social creatures. And through that, wolves evolved into dogs, and now we have all these different varieties of dogs, and a lot of them are based on our needs, what we need, right? So do we need a guard dog? Do we need a watchdog? Do we need a helper dog to help the blind walk around? Do we need a bomb sniffing dog? So we've bred dogs to fit the roles that we need, whether it was done by shepherds or by the military, right? Now, we're never going to expect, it's quite comical if we were to expect, and in fact, they'll make cartoons of it, which are comedies, that dogs will revolt and take over the world and all that. So in the same light, it's just as silly to think that's going to happen with machines. These machines have to evolve with us, right, to fit our needs, to do the things that we need to get done. They're not going to outperform us in every case right off the bat, right? They're going to maybe perform as well or a little bit better than us on some tasks, and other tasks for sure they could calculate things much faster, but that doesn't make them sentient. right away. So, an intelligent artifacts, the actual artifact part is that intelligence emerges from these conditions of the environment, the configuration of these agents that we have, which for biological entities that's our DNA, as well as the process, the cognition process, that algorithm, right? So in a computer, it's an algorithm, but it's an algorithm for biological entities as well, just implemented differently, right?
Exactly.
Yeah. So I don't see this doomsday scenario everyone's worried about, because we will be controlling them all the way through. You wouldn't let your teenage kid get behind your car and start driving down the street without having taught him or her how to drive a car safely and explain them all the rules of safety and all the rules for driving a vehicle. Put on your seatbelt, make sure you look all around you before you pull out of the parking spot. Similarly, before we give the keys to anything that's dangerous to an AI, we'll train them and make sure by testing them that they qualify for that position.
Absolutely. I think that, as it stands right now, there's a lot of different applications for AI, and the training in specific contexts, getting it to move from one context to another without that necessary training is the part that's a huge limiting factor. I think another thing, I was having a conversation with somebody not that long ago where we were just talking about almost the poetic nature of our kind of fear of AI taking over, like the thing that we created becoming the thing that we can't control anymore, and now we have to fight against to save humanity, like that kind of idea or concept.
Right.
Yeah. I would like to kind of. Oh, go ahead.
I think actually one danger that does come out of AIs today is the way that they're actually being implemented, and we should always note this, that there is inherent bias in the way people, regardless of what their intentions are, they could have the best intentions, but there is bias in the way they model their systems. And if we're talking about an AI system, if we have an engineer that's modeling an AI system or modeling the data that goes into the AI system, it's bound to have bias in it. So you have to have ways of removing all of that human bias from entering into an AI, because that actually is dangerous.
Yes.
Those are the I wouldn't say a doomsday scenario, but a very dangerous scenario.
It's a dangerous application of the technology, especially because it's hard to know your limitations, right? As a human being, like when you're programming something, you don't just think like, oh, like I have a limitation or a blind spot in this area. Otherwise, it wouldn't be a limitation or a blind spot.
Exactly.
But yeah, there's definitely the challenge, the very real and present challenge of bias in AI. I'd like to kind of talk to you a little bit about like the early stages of intelligent artifacts, like how, like what was that beginning part like of the founding of it and like that first bit of time.
Right. So I started developing the framework while I was still at the Federal Reserve. And I had a notebook from when I was a kid with all these scribblings of how a general AI system should function, the features it should have, the modules that should exist. And, I had kept that notebook with me. And after I took those courses, I went back to that notebook and said, well, this still seems like it would work. Why don't I start developing this? And I started developing it, on my own time, nights and weekends, and on the subway ride to and from work. And I actually wanted to pitch it to the Federal Reserve so that they could use it for all these different problems that obviously something like the Federal Reserve would have, from cybersecurity to audits to all sorts of things. But after a while, I actually put the original proof of concept on the internet and started getting some calls from local startups asking if I would join them in helping them build a product using the guy's framework. And while I was there at the Federal Reserve, it's a great job in cybersecurity, and I eventually switched over to software testing and enjoyed that very much as well. So I had no intention of leaving, such a great institution as that, with a really cool career, to work at a startup with 9 out of 10 of them failing in the first 2 years. I'm not a big risk taker, so I really didn't want to take that on. But after a while, there were a few startups that were offering some generous amounts to do the work. So I went back to my management at the Fed, and I asked if I could do this on the side. And I figured, well, at the very least, what I could do is take that proof of concept that I had created and expand on it and just grow it using real-world data, real-world problems, because usually AI is solved in some pristine lab environment, and when you put it in the real world, it fails miserably. So I wanted to do it the other way, have real-world problems and data starting with. And so the Fed actually, they took some time to give me that permission to actually do this. And in the meantime, more and more potential customers had reached out to me. So I had made a deal with them, the customers, that I wouldn't work for any of them specifically, but I would license my technology and consult for them through an incorporated entity, which is Intelligent Artifacts. And that was actually working out really well, so well that within a few months afterwards, I realized that I'm actually having a lot more fun doing this. Even though I loved what I was doing at the Fed, I was having so much more fun doing this, and I was making so much more money that I could focus my entire time to AGI.
That sounds like a really perfect way to kind of make the leap from where you were working to kind of a startup, where the startup is not quite as risky as a lot of the 9 out of 10 that you may have been talking about previously.
Right.
Yeah. I'd love to kind of early on just kind of define some terms with you in terms of like, what is artificial general intelligence, and how is it different than artificial intelligence as it exists now, so that our listeners are very clear about those two terms?
Yeah, that is actually a really great question, because there's a lot of confusion around it. So people think that AGI, which is also sometimes called strong intelligence, versus the weak intelligence or narrow AI, they think that AGI means human-level machine intelligence, meaning that you have a system that can solve problems exactly like a human can, or better, or on par with a human on all these different domains. So you go to a different vertical, different type of problem set, different type of data set, and the machine can solve those problems just as well as a human. The way we look at AGI, and we think it needed to be redefined. We actually have an article up on our blog about redefining AGI, so that it's something that makes sense and allows us to develop towards human-level machine intelligence. We look at AGI as not specific to any species like human, but general for any animal, right? So we could take an octopus. Octopuses are intelligent. Dogs are intelligent. Cats are intelligent. We have chimpanzees that can do really interesting things. Crows solve problems, right? So there's a lot of intelligence already in the animal world. And it's not just human intelligence. Human intelligence has additional features, or the magnitude of what it does might be a little bit greater than other animals. But it's not like one day God came out and created humans and suddenly there's this perfect brain that exists. Our brains had to evolve through nature.
Mm-hmm.
So similarly, we believe that to get to human level AGI, you actually have to have a framework that allows for any type of level of AGI, any type of machine intelligence. And the idea is to configure that framework in such a way that it solves the problems within the environment that that agent is in.
Mm-hmm.
Right. So whether it is a cybersecurity agent that's monitoring a network and trying to reduce malicious attacks, or it's a product recommendation engine, and you want the better recommendations made to your customers. Those are completely different domains, but you should be able to use exactly the same process, the same framework
Mm-hmm.
to get ahead and get good quality predictions in those really different domains, and over time evolve that specific configuration to do better and better and better. Just like animals have evolved from their small creatures that manage to survive somehow to large complex creatures that are able to thrive within
Mm-hmm.
their environments.
Is built within that framework the ability for the intelligence to evolve naturally or organically, or is it going to take like human iteration and kind of manipulation, like to get it to go there?
Yeah, so that is a great question, and the fun part of it is that the answer is yes to both.
Okay.
Right? We've built the framework so that we can run genetic algorithms over those configuration files, and we call those configuration files genomes for obvious reasons now.
Yep.
And that'll allow these agents to evolve autonomously within their environment. But we also want to have some controls on that. And the reason we have controls isn't because of some kind of doomsday scenario,
Yeah.
but for computing resources, right? We could evolve something to be so optimized in an environment, but it takes so much resources to produce let's say, a recommendation for a type of ice cream you should have. And it's like, okay, do we really want that level of sophistication for recommending ice cream flavors? So we have controls really to reduce the computing needs of this, and that's where the human can come in and say, look, this is actually what I'm really interested in. Get us into this accuracy or precision metric or whatever other metric is needed for that problem domain, and we can have those genetic algorithms evolve these agents using live data to reconfigure themselves and perform better than their previous generations.
I see. I think it'd be interesting to kind of go back a little bit to something that you talked about earlier on, because, I don't have the technical background. My background is in marketing. So I always thought that artificial intelligence was some sort of like new thing, and it's kind of evolved very recently. And kind of going back, you said that in the 1980s, it was something that they said would only be 10 years and then everything would be done. What were the problems that they were solving at that time, and what were some of the beliefs about, I guess, the end game for artificial intelligence that could be accomplished in 10 years?
Yeah, so let's go through the history of AI in briefly, right?
Yeah.
So we could say that modern AI kind of started back in the 70s. And at that time, and we'll just to kind of condense the whole thing, there were two schools of thought. One was the connectionist school, which are the neural nets. They're the bottom-up approach, right, and highly statistical just because of the implementation. but doesn't have to be statistical. But that was one school of thought where their proponents believed that this was the path to human level machine intelligence or an AGI in the sense of building any kind of solution that we would ever need. The other was a top-down approach called expert systems, otherwise known as production systems. And their implementations were these things called cognitive architectures, where you would get an expert to write down the rules of engagement for different problems. And those rules would be fed into the machine as instructions, right?
Mm-hmm.
So though the connectionist bottom-up approach, they learned directly from data, the top-down expert systems require the experts to provide basically the data.
I see.
They couldn't learn directly from the raw data.
Would an expert system be like an example when like AI was programmed to win in chess against grandmasters or something like that?
So IBM's Deep Blue is a bit of a mix, and this is kind of like the dirty secret of that whole chess game. So Deep Blue was a brute force algorithm, but they also had an expert that knew how Garry Kasparov played. So they were able to have that expert generate rules, and they put it into the system to allow that system to anticipate those moves, which reduced some of like the brute force calculations needed. But anyway, I think people today, the practitioners today in AI, don't really consider Deep Blue an AI system. It's a brute forcing algorithm with some expert hand-holding.
Okay, I see.
I mean, very, very impressive for what it did.
Mm-hmm.
Just like Watson is very impressive for what it did, and quite amazing, I have to say, that IBM put together Watson. Unfortunately, I think they try to use it in applications that maybe it's not really good for. They didn't really take advantage of the strengths of Watson. But then again, these are things that are kind of built towards specific problems, and Watson seems to be one of those systems, which is really an umbrella system. So every one-off comes out as a new application and entered into the system, and they hope that that one-off could be used in so many different applications. But of course, it's a one-off,
Yep.
So it doesn't really scale well. So those are kind of like the differences between narrow AI and general AI, where narrow AI is something that works in one specific domain quite well. But if you change the environment just a little bit or ask of it something just a little bit different, it doesn't do well at all.
I see. I would love to, I think if people have been reading news in the tech industry and tech world, they may have come across intelligent artifacts because of an award that you guys received. Can you kind of discuss that a little bit?
So we have won awards based on the concept of sensor fusion. So sensor fusion is the idea of if you have multiple disparate sensors. So for example, you have radar and you have camera, visual camera, and maybe you have infrared cameras as well. You have audio, you have thermometers, you have accelerometers. All these different types of sensors can provide information for, let's say, a vehicle, right? And in some cases, it could be like a jet fighter. So the concept of sensor fusion is, well, sure, we could get a lot of information extracted from each one of these sensors individually, but what if we were to aggregate them together and look at all of their data within the context of each other? Does that provide us new advantages that weren't quite visible just by looking at the raw data of any one of those sensors individually. So the way our framework works is designed just because of the AGI component of it, the universality of how to get data into the system. It was actually a natural fit for sensor fusion projects and allows us to ingest data from any type of data source, bring them together underneath a common symbolic framework, which is also connectionist. And we were talking earlier about the expert systems and the connectionist systems, who those two schools of thought believed that they were completely incompatible with each other. It turns out that they're not. You can't just take an expert system and a neural net and try to glue them together. You can't just have let's just add symbolic processing on top of our neural networks at some point. And there are people doing that, and I get why they're doing it, and unfortunately, I think they're painting themselves into a corner. If instead you throw everything out and know that, well, ultimately we need a symbolic system that is connectionist. What kind of math is needed to allow symbols to work between these different nodes, to be abstracted through these information processing modules, to give an oversight of all of the data that is fed in. So basically, that's part of that whole sensor fusion thing, where you bring in data from multiple sources. You're able to incorporate all that data together, so fuse them in some sense, and abstract out new information that you wouldn't have been able to even observe just by looking at each one individually.
Absolutely. It's like, instead of just trying to force these two things together because they have benefits that you want to kind of take from both of them, you start from scratch, and they're delicately intertwined together because there was a purpose for them to be together.
Correct. That's right.
Yeah, I'd like to hear a little bit about the website that, like, Intelligent Artifacts. It talks about traceable machine learning.
Right.
I'd like to hear a little bit about that technology and the importance of it.
Yeah. So when I first started Intelligent Artifacts, this is now over 12 years, about 13 years ago. Back then, no industry was talking about AI. So trying to go into a potential customer and tell them that they needed AI for what they were doing was always a hard sell. They're like, well, what is AI? Why do I need it? I don't understand why I need this at all. And almost within a couple of days after, and Google gets the credit for this, after they put out TensorFlow, and then IBM had their Watson product out as well. It was almost like overnight that the conversations with customers changed from I don't understand why I need AI to I need AI. I don't understand why I need it.
Yeah.
Can you tell me and help us build it? And throughout that period of time, as more and more customers started implementing AI, and quite never into production, unfortunately, for a lot of these cases, they also realized, and the reason is, they realized that these systems weren't explainable, right? So, for example, if you're in the fintech world and you need to, if you're providing somebody a loan, right, and you're using an algorithm or a model to provide somebody a loan, you have to be able to explain that that model works without bias, that you're not providing loans based on gender or race or any other protected quality. With the neural nets, so neural nets had a new rise, and going back to like the brief history of AI, neural nets have this new rise again because of TensorFlow. TensorFlow is a framework that allowed people to build neural nets very easily and quickly and process data rapidly. Whereas before, building neural nets was actually easy for small nets, but if you start getting more complicated, you had to bring in your GPU and try to manage all of that, all those processes. It's not so easy. And with the cost of GPUs going down tremendously, and NVIDIA has been doing a great job of that, this new wave of AI has been rising. But this new wave right now is, I would say, almost 99% all about neural nets. And we know from the first AI winter that neural nets can't be the final solution for machine intelligence. The roadblocks that they had back then, and I'm talking about like the fundamental roadblocks, not just some minor implementations that we could overcome and speed and all these other things, but their fundamental flaws will prevent us from actually building these systems in a way that we could understand and control and guarantee that they're safe and useful. So that, after the first AI winter, we have this new AI world, and the customers now have been looking at these black box solutions and saying, well, thanks for the answers from this AI system, but first off, how did it get it? Can you explain why it's giving me this answer? So explainability became a new buzzword, and a new term was created, XAI, which stands for Explainable AI. And that went on for a little bit. And of course, a lot of startups and marketing teams try to capture that and say, hey, yeah, we have explainable AI. And look, this is how we're explaining it. And they would use like heat maps and stuff. And a regular person looking at this says, well, you said you just explained it to me, but I still don't understand it. So exactly. I'm not sure if that was actually an explanation. So
coming from a guy in marketing, it sounds like a marketing thing.
Right. So the new concept of interpretable AI came out, right? So that's like the new buzzword, interpretable AI, which says, okay, yeah, you've quote explained it, but do we understand that explanation? So we see that, yeah, it's a buzzword for today. But what we see going forward is a need beyond that. Explainability and interpretability are great, but once you have that explanation, once you've understood what's happened, what are you going to do with that? Right? And this is where traceability and editability come in. And we call this the EXCITE model. So EXCITE stands for Explainable, Computable, Interpretable, Traceable, and Editable AI. And what we mean by traceable is that when the AI gives a prediction, we should be able to trace that prediction all the way through the system back to the specific data record that was ingested during training time, to say it's because of that training record or that set of training records that produced this prediction or this set of predictions.
I see.
And if there is a problem with the prediction, so for example, if this is on a car and the car crashes into a pedestrian and we want to know why that happened, great, we can find out why that happened, but now we can actually do something about it to guarantee that it doesn't happen again. So by tracing back to the original record, say, well, the system believed that this wasn't a person. This was something that it could just drive right through. Because of that one record or that set of records there, you should be able to edit those records or delete them or replace them, and do that in such a way that guarantees that accident cannot happen again. And that's what we mean by the traceable and editable components of it.
It sounds like a framework that would also work perfectly for trying to understand how to eliminate bias, right? Like if you can kind of pinpoint the area of the model that produced the biased outcome, it'd be a lot easier to extinguish it.
Yeah, that's very true. So using that Excite model, analysts can actually go and find out if their AIs, if their AI is actually excitable, if it's an excitable AI, they could find out if there are biases, where those biases are, and remove them. For us, we actually flip it around, and we don't allow those biases to get introduced into the system in the first place through an engineer, right? Because we don't model the incoming data. Right? So modeling the data means you're throwing stuff out that you think is not important. You're putting stuff in that you think is important. We just say, well, all the data that you have, just put it in there. Now, there's also bias in the collection of the data. So when we were talking a little bit earlier about, the data and the memory and the algorithm components of it, this data part of it has to be always investigated too. It's a critical component of machine learning. So how that data is collected, where it's collected from, what kind of values and what kind of fields are included in that data are important parts of a complete AI system.
I see. When you say a system is excitable, does that mean that it's something where the Excite framework can be applied to it after the fact, like after it's already been built out?
That's correct. So you could take this Excite model and look at any AI technology, any AI technique, and say, well, can we explain using this technique or this technology? Can we interpret any of this data? Can we trace anything back to their source records so that we can edit them? And the computable part, so Excite to see is actually computable. Is it deterministic? Can we first assure that we get answers back in a specified time frame? And is that always the case that when we put in this data, we always get that result, regardless of anything else? And those are really important things, especially for safety critical industries.
I'd like to explore safety critical a little bit more with you. What are some of the challenges that are safety critical industries are facing, as well as the solutions that you believe are most pressing for them?
Yeah, so the biggest challenge that these safety critical industries are facing right now is this whole lack of excitability in their AI systems. Unfortunately, right now, when we talk to really smart engineers in their fields in aerospace and automotive, particularly, their only view of AI is what probably the layperson thinks of as well, which are neural nets, right? They think that's, well, all of AI that we're talking about today is neural nets, and we need GPUs, and we need this, and we need that, and there's no other way of doing AI except neural nets. And that's simply not true. So we try to educate these groups of engineers that there are other AI techniques and other machine learning techniques that are not stochastic. They are deterministic. You can have these excitable technologies. Neural nets are not excitable in any way. And I think, as they try to add on explainability and interpretability into them, each component they seem to add on just complicates it a bit more, which reduces the overall interpretability of the full systems. So they're kind of going in the wrong direction by looking at neural nets. Yet those industries, especially the aerospace industry, where a lot of these airframers want to automate flights completely, from takeoff to landing and everything in between. Right now, there is a group called the G34, which is a subgroup of the SAE, who had originally developed a safety standard for aerospace. So every commercial liner has to pass and get this certification. It's called DO-178C. And without that certification, their planes can't fly. And if there's an accident, like there had been not too long ago, those aircraft and every system in there has to get that certification all over again. So they have to identify why something went wrong, why things went wrong, why did people die? How do you guarantee that this isn't going to happen again? They have to go through all these systems and assure the public that, yeah, now we're safe. We found what the problem was. We know exactly what happened. There's no guesswork. We don't have to try to interpret things. We know exactly what happened. And we fixed that, and we did it in such a way that guarantees that that failure won't happen again. So the challenge for the aerospace industry has been that this neural nets being prominent, that they are trying to relax, or some people within this G34, which is looking at how to create a standard to allow neural nets to get certified. And in just every way you look at it, it seems like you have to relax some of the safety regulations to do that.
I see.
Or limit the use of neural nets so extremely that you're really not giving them any kind of autonomy at all, which is defeating the point of using AI in aircraft in the first place. So, I've already spoken with some members and groups within that G34 to explain to them that there are other options. We shouldn't relax our safety regulations, especially for aircraft. I already have trouble flying, and I know their aircraft are very safe to begin with. So add to it, the anxiety of that uncertainty that there's a neural net running this thing, and we don't know what it's going to do at the end of the day. So we really want those safety regulations not relaxed at all. We want the DO-178C preserved the way it is, which already covers so much safety regulations. And we know our framework is actually capable of getting certified for the DO-178C, and we're going through that process right now.
So would you say that that's kind of a situation where people are running into the limitations of neural nets, but they don't know that there's an alternative out there, so they're trying to allow neural nets to continue on existing?
Yeah, absolutely. I mean, progress takes risk, right? And if you're a scientist, you're an engineer, and you're trying to develop new things, you realize, new things inherently have some risk to it. So you're trying to balance that risk of, is this going to injure people? Is it going to take lives? Is it going to destroy property? You're trying to balance all that risk with, well, what benefits do we get from doing this? How much more efficient would flights be? How much safer could they be if an AI was running it? Versus how much more dangerous would it be? Obviously, nobody wants to put something that's inherently dangerous into an aircraft and let it fly. The intent of it is to make everything safer and more efficient. But the problem is that because of their black box features, that you're never going to be able to repair something and guarantee that it's actually safe.
Absolutely. I'd love to hear what you foresee, like within the next 10 years, where the technology for intelligent artifacts is heading. Like, what is your vision for 10 years from now?
Yeah. So the framework that we've already built has our main module, which is called cognitive processor, which is what it does when it takes data coming in and extracts information from it and does all these great things. And we have these things we call manipulatives that allow a lot more flexibility back into the system, since the cognitive processor's job is actually to take away tremendous amounts of flexibility to be a very rigid process. The next step is to add reasoning to our system. So since our system is symbolic, we're able to take the work that was done back in the 70s and 80s and apply it to our framework to basically add reasoning capabilities to our agents. So right now our agents make predictions based on what they've learned. In the future, our agents are going to make predictions on things that it's never seen before, but it could make reasonable assumptions about because it's similar to other things that might not be in the same domain as what it just saw it in. It could reason about things like, well, numbers. If you go up in numbers, that means some magnitude is increasing. It could reason about like language. So there's a lot of things that come when we create this reasoning module for it. But I think that's in the next, less than 10 years, but at least around 5.
I see. What do you think are some of the ways that this type of technology maybe interacts with people, like just in their everyday life? Maybe some ways that are not necessarily known to the general public.
Right. Well, Mark, the thing is that one thing that I really hate is this object that's in front of me right now, this computer, right? It's got a keyboard, which makes me like have to attach my fingers to it throughout the whole day. I'm staring at the screen, 8 to 12 hours at a time to get work done. And if you look around at these cube farms at offices, you have millions of people every day sitting at this desk with a computer, and they're attached to it through their fingers, telling the computer exactly what to do, just so that they could get work done. Ultimately, what I would like to do is eliminate these computers, have machines that you could just talk to and, hey, can you get this done for me? Give us our sales report from last year, and figure out what would happen if we did this different. Play some scenarios, figure it out. Just tell it. You do the work instead of me doing the work for you. So ultimately, that's where I want the technology to go, and obviously into robotics, into cars, into cell phones. Having a personal assistant would be great, of course, for everyone. There's all these tasks I have to get done throughout the day, and I just wish I could just pass it off to somebody and say, hey, can you get this stuff done? Because I don't want to have to call, the plumber to have this fixed and talk to them about like what needs to be installed, and, you figure out if we should do it or not, right? So in a way, you're kind of taking autonomy away from yourself for all these mundane tasks that you have to do throughout your life, but that frees you up to spend that time doing other things. Look, at best, we have, let's say, 100 years to live. And in the first 20 to 30 years, you're really trying to figure out, I have to learn all this stuff before I could do anything. So you're figuring all that out. So you've kind of lost those years in making progress with anything else. And then, after you turn 60 or turn 70, you want to retire because you also want to do other things and travel and just sit at the beach all day long or whatever it is retired people do, because I don't ever want to retire. But to be able to use that time in between more efficiently, I think would be a real gift to humanity. So even though you live for 100 years, we could expand that productive time out a lot more. We could give people that time that they have lost doing all these other things just by having real AGIs in the world.
Absolutely. I mean, this is a completely different scenario, but it has probably a similar feeling in the sense that, like, I remember what it felt like from going from a 1 hour each way commute to go to work to moving to an area that's only 5 minutes away from my office, and just like, wow, I have all of this extra time. What do I do with it? You know? And now we're just kind of in a scenario where now you just have to prioritize what to do with that time.
Right, exactly. And, that's where the fun parts of life come in, right?
Exactly. I think one other thing that I'd love to ask before we get going, because I obviously want to be respectful of your time, is like, what is one misconception that people tend to have about AI that you would like to set the record straight on?
That it's much more advanced right now than it actually is. I've had people tell me their nightmare scenarios, and they're thinking like, "Well, AIs are almost there with this," and it's like, no, the hype is there. The hype is for sure there. AIs aren't anywhere near it, so everyone could just take a deep breath, relax. AIs aren't taking over the world, but just pay attention to your social media more and make sure that it's not bots telling you what you should believe and what you should think, because that's actually dangerous. But AIs themselves aren't taking over the world.
Absolutely. I think that's it's a good thing to tell people, especially some maybe more prone to conspiracy theories than others.
Right.
And also, before we finish this, I would love to ask if there's a way that people can find out more about intelligent artifacts, about you, and the projects that you guys are working on.
Sure. So they could go to our website, intelligent-artifacts.com. We have a lot of information up there. We have blogs and articles. They could go to our Twitter account, and hopefully you could add that later, because I can't remember it. Again,
Absolutely.
I stay off social media
as
much as possible, but our team handles all of that. I am on LinkedIn as well. If anybody wants to connect with me on LinkedIn, I'm quite easy to find there. But yeah, those are the main ones.
Okay, I'd be happy to include all three of those links in our description. No problem. Okay.
Thank you.
Thank you so much, Sevak. It's been a pleasure talking with you.
Likewise.
All right, take care.
Have a great day. Thank you very much. Bye-bye.
That concludes today's episode. We want to thank you for listening all the way to the end. This episode was brought to you by Mars Crowd, your one-stop data labeling and collection service provider. For more info, feel free to click the website link in the description. We look forward to you tuning in for our next episode on how AI is changing society.